Hey guys, it's Collatz. I'm going to show you a solution to 3n plus 1. Let's just get into it. There's plenty of videos that explain this process. I'm just going to show you the solution. Starting information, any positive whole number. If it's odd, I'm going to multiply by 3 and add 1. If it's even, I'm going to divide by 2. I'm going to simplify the odd numbers into two steps at once. So 3n plus 1 divided by 2. And I use positions, so I have the special formula that I made to give me the positions. The position is n minus 1 divided by 2. That's my position. Then I add 1, and then I add the number, and that gives me the same results that 3n plus 1 divided by 2 will do. And if I want to get from 4 to 1, I would use n minus 1 divided by 3 and go right back to 1 from 4. I use positions. So position 0, I'm going to start at 0 for even, 1 for odd, and then increment up 2 for each side. So position 1 would be 2 and 3, 2 would be 4 and 5, and so on. The formulas are to get from the position to the number, I'm going to take the position times 2 plus 1, and for even, I would use position times 2. Alright, and to find the number of the position, I would take odd n minus 1 divided by 2, and even divide the number by 2. What does knowing the position tell us? So even, from even numbers, I can find all the positions. Even are going to split 50-50 for even and odd results. And when I do the divide by 2, right, I'm losing half of the number that I started with. With an odd number, right, my max increase in positions is 60 to 67%. And this is a lot less than my cuts are from the even numbers. From odd numbers, I cannot reach all positions. Right? All multiples of 3 cannot be reached. Right? The positions. So position 3, 6, 9, 12, and so on cannot be reached. So position 3 is the even number 6 and the odd number 7. Half of the numbers will reach a double even, right? So 1 goes to 4, then to 2. 7, is it 7? 5 goes to 16, 8, and 4, so it actually goes 3 evens. 9 goes 28, 14, 13 goes 40, 20, 10. Alright, so half of my odd numbers are going to have this double even in a row. Alright, 3n plus 1 hits only every third number on its own. So if you just look at 1 goes to 4, 3 goes to 10, 5 goes to 16, we're skipping 2 numbers in between all these. And every fourth odd number is going to hit 3 even numbers. So we have all these items that cause us to hit multiple numbers that are going to divide by 2. right? So even though we're going up in numbers, we have a lot of even numbers that we're hitting multiple times in a row. So the other half will be they're going to hit one even and then go back to an odd. Right, so 3 goes to 10, then back to 5, which is odd. 7 goes to 22, then back to 11. 11 goes to 34, then back to 17. So you're hitting 1/3 of the odd positions this way. And I'll give you a visual of that here in a little bit. What does knowing the positions tell us? Alright, odds move up in steps. I've not heard anybody talk about this when looking at this conjecture. Odd positions with only one even move up in increasing positions. Right, the formulas for this is the step times 2 plus n gives you the result, right? And if I don't know the step, I can take the result minus n divided by 2 to give me the step I'm on. So I can use those formulas back and forth to find where I'm at. So when I was playing with numbers in the billion range, this formula helped me to figure out where I was at, right? And if you know, I was looking for certain numbers, and I was able to use this formula to find out, you know, what step I was at. 3 moves up one odd number to 5. 7 moves up 2 steps, right? It skips 9, goes to 11. 11 skips to 17, so it goes up 3 numbers. 15 goes up 4 to 23, right? And so on. If the step is odd, it leads to a double even. Right, so 3 goes to 5, and 5 has 16 and 8. It actually goes to, you know, 4 after that. If the step is even, then these cycles, right, go between even and odd again. So we just have another odd even cycle happening. If the step can be divided by 2 even numbers, then it will continue upwards. Right, it'll hit another even step. So 1 goes up only 1 step, 2 goes up 2 steps, so it's going to hit the next step, right? 3. 3 is going to go up 3, so it's going to land between step 4 and 5, and then 4 is going to go up, right? It's going to go up 4 numbers, right? So step 2 is 2 times 1. Step 4 is 2 times 2. Step 6 is 2 times 3, and so on. And multiples of 2 give us a new high trend. So step 2, 4, 8, 16, 32. These steps are going to give us a new high trend. And we'll look at that here in a little bit. Alright, so if I enter the number 7, right, I get these. Right, it's going to go from 7 to 11, 11 to 17, 17 to 26. Right, so you have a a new high cycle of 3, right? So I have these 3 steps right off the bat that go straight up, and then it comes down to 1 in, right, 16 cycles. 11 is below its starting point. This seems to be the fascinating part as to how long it gets below. For me, it's not really a thing. The trend, though, is 3. Right, this is the first number that has a upwards trend of 3. Right, and it's the step 2. The next one is 15. Awesome. Right, it starts off with a upward trend of 4. It's below its starting point in 11 cycles, 17 cycles total, and like I said, it starts off with a trend of 4. So number 27 is the one that fascinates everybody. They always talk about this one, and what you're going to see is that it has this number 31 in it. 31 is the first time you have a cycle of 5 in an upward trend, right? This is the first time that it should be possible. 27 actually beats it to that because of this falling into it, right? It goes 27, 41, 41, 62, 62 divides into 31. So you have this strange pattern where this one hits this new cycle trend. But as you go through this one, you have this unique phenomenon where it hits a 6 trend as well, right? And this is a normal average trend for the number 319, right? That number is between 256 and 512. So 512 is going to be the right. 511 is going to be the start of a new trend of 9, I believe. And so 6 is like the common, right? That's the most used trend in those two number ranges from 512 to 256, right? But I think this one is the one that throws everything off because we ignore the 31 to 161 5-high trend that's hidden in it because it's a 6. Right, it's the only time it happens from 1 to a billion. And then here's the rest of that cycle. So you start at 27, it takes 96 cycles to get below your starting point, 111 cycles, and the trend of 6, which is a false reality because it's just playing with a low trend of a higher group, right? So what I did is I took I started looking at the cycles, right? How many cycles for individual numbers. So 9, right, is a single digit, and it's the one with the most cycles of 19, and it's a trend of 3. And so a 2-digit number, 97, has the most cycles, trend of 6. 871. See, so we're way beyond 27 and 31, and we're still trending at 6. 4-digit number trends at 6. We get to a 5-digit number, we trend at 9. Then we go back to the trend of 8, trend of 9 in the millions, 2-digit million number, a trend of 10, and then a trend of 10 on this one. And I tried to do the first billion number, and it was out of the parameter reach for the code that I'd written. So my next question was, well, is there a trend bigger than 10? And so I started, just started off at 1 and searching through every number looking for a higher trend. And the first one I found is 1819, a trend of 11. And then I found a trend of 12. Right, 1819 is unique in the trend of 11 belongs, well, I think we're going to see it here in a second. So I found a 13, 14, 15, 16, 17, 18, 19. At 19, I decided to skip 20 for 500,000 plus numbers. And then I found a 21, but I had turned on show me 20 and 21, right? Anything higher than 19, because I'd went through another 500,000 numbers and hadn't found a 21, so I was like, well, let's make sure that 19's not the max or 20's not the max. So I turned it on and I got these two numbers in a row, 150, 151, and they were right an even number and an odd. So I was like, right, the below cycle for 150, it immediately went down and then it went up after that 20 cycles in a row. Alright, and then 151 went straight up 21 times. And so I played around up to 5 million numbers and figured I had enough data to know that these trends were happening in some type of pattern. And so I asked myself, where's the first 10 trend, right? Because the million number cycles were 10 trends. So I was like, well, what's the smallest number that has a 10 trend? And I found this one, 1023, is a 10 trend. And so come to find out, it's the very first 10 trend. And the number right before it, 1022, is a 9 trend. And 1020, or 1022, 1024 is a 0 trend. Alright, so 1024 goes straight to 1, right? Never goes up one time. So I found that interesting, and then I took I went looking for the number that was 20, so if you divide 209, 150, you get this number. And like I said, I plugged in 152 and found that it's a 0 trend as well. So it's it's a multiple of 2. And that's when I started looking very specifically at when these trends start, right? So you start at 3, you have 7 cycles, right? It's the first step, and it's a trend of 2. It's the very first time you have a trend of 2. You start at number 7, it's the second step, right? And it's 16 cycles, trend of 3. 15 is step 4, and it's a trend of 4. 31 is step 8, and it's our anomaly. It's a trend of 5, right? You go straight up 5 steps or 5 cycles from 31, and then it has this extra large, you know, trend of 6 in the middle of it. 63, right, is the lowest number with a trend of 6. 127 is the lowest number with a trend of 7. 255 is the lowest number with a trend of 8. 511 is the lowest number with a trend of 9. 1023, right, lowest number with a trend of 10. And then I went through all of them, and I'm just posting every 5th one. Right, and so at 1 billion, right, you have your trend of 30, and it's, you know, this ridiculous step. Right, so this is the pattern that it uses to, you're not going to find a lower number with a trend of 30, right? If I double my step and get the new start number, it will be 31. And I double it or multiply by 2 again, I'll get 32, and so on. This will not end, right? And we've done numbers way beyond 1 billion to have proved that part of it. So just to give you a little visual of how I put these formulas together. So you can see the blue numbers, right? If I take my odd 1, multiply it by 3, add 1, it's 4. So you can see that in my even column, if I just do the simple 3n plus 1, I can only hit every 3rd even number. And these are still going to alternate even and odd as their results. If I take my odd numbers and do 2 steps together divided by 2, and if you look at my special formula, you see 2, 5, 8, 11. This is where you're going to end up after 2 steps. And then I show the positions. The odd number 1 ends up at 2, which is a position 1. The next one ends up at position 2, which is 5. And so you see the dark green numbers where they land. They alternate back and forth between even and then odd. And if you notice that if we look at our positions, there's no positions that the ones that are grayed out cannot be obtained from an odd number, right? So you can't get to 6 or 7, 12, 13, 18, 19. I have put brown in the numbers that are triple even numbers. So if you put in the number 5, you're going to go 16, 8, 4, and so on. 13, we're going to go 40, 28, 10, and then 21 goes 64, 32, 16, straight down to 1. So you go this 1 step up and then straight down. And then the steps are in purple, and you can see that the odd steps right? The brown odd steps send you to a triple even numbers. Red ones send you to a double even. And then the others, 2, 4, 6, 8, the 2, 4, 8 are going to give you your new high trends, and then the others are just some randomness that's happening, right? 6 is gonna go up to 35. 35 is gonna go to 53. 53 is gonna be a triple 3 at that point, right? Which is just off the scale of this. But one thing I will say that if I remove the number 1, all these numbers that aren't static disappear, right? They're all based on the number 1 being there. So I can punch in any number into there and it will start building the numbers out from there because it's all based on the number 1. So the question of reverse engineering, how can I get from 1 to every number, right? This is the formula that does it. So I can't think of anything else that should help with this. This is all the information you should need to write a proof on this. Thanks for listening.